Well, hello again everybody. Well, I'm afraid this week has been just one of those weeks where, everything's gone not quite right, nothing's gone to plan, and all the videos that I was making all went totally wrong. But what I did today was go to the National Radio Ham Fest in Newark, and I didn't feel as though I had quite enough junk, so I thought just to please my wife I would go and buy some more. So today it's just going to be a little bit of a show and tell video, I think. So let's see what we bought. No peeking. So you're into electronics. I'm sure that most of you have been to these radio ham kind of fairs where, they have stalls with various old surplus electronics, and I've got to admit it seems to be getting a little bit less and less every year. I think maybe a few less people are into electronics. So, you go rummaging through the junk box looking for treasures. So let's see what we've got here. Well, again, something that I found that I've been lacking recently is just battery holders, because I've done quite a few little projects which are battery powered. In fact, I've got one here. I don't even remember in one of the other videos I did. I think I featured this, but I'll put a link to one of a video that Simon did where I sent him a kit to build. So basically, I bought some of these cheap kits from China, and again, if I can find them, I'll put a link in. And it's actually it's a digital clock, and it's got a thermometer on it. In fact, let me plug it in, and then you can see it. So basically, it's powered from USB, and I'm guessing it also takes a coin cell that would go here. And yeah, it's basically just what would come under the description as being a blinker. I'm assuming that the actual button cell is to back up the the memory to keep the clock running, but it doesn't actually light up until you actually plug it in. And as I say, it's built from a kit, this, and it's got a combination of quite a lot of surface mount components, and also a few standard through-hole ICs. It's got push buttons and capacitors. It's got this little USB socket. It's got a buzzer here. I'm guessing it's a bleeper, but I haven't figured out how to make it bleep yet. Let's plug it in. So there's a bit of a close-up of it. As you can see, it's got some surface mount chips. It's got a few transistors, quite a lot of resistors and some capacitors. And on the other side of it, it's got the, well, it's some kind of Atmel. Is it 80? Is that an 80 mega? Is that? I don't know what that is. It's an Atmel chip, some form of microcontroller. It's also got this chip here, which I actually think is some kind of timer IC. I haven't actually looked this up. It doesn't actually come with any instructions, this, so you kind of have to make it up on as you go along. There's actually one of those Chinglish instruction sheets which doesn't give you a circuit diagram, it just tells you, and the translation says it tells you how to weld it together. So apparently you don't solder it, you actually have to weld this thing together. But yeah, I think it was about, I think I paid about £4 for this. It might have been even less than that. And the reality is, for what I paid for it, you probably couldn't buy the components. So yeah, I thought that was quite a lot of fun. It says it's an AT89S52. I'm not sure what the other chip is. I think it might be some form of real-time clock. Can I see it? It looks as though it could be a DS1302. And I say it's a clock. Well, it's got a, I think I'm pretty sure it's a clock because it's got a clock crystal next to it. Yeah, I'm actually just wondering now if maybe this coin cell backs up. Maybe this is a real-time clock module, because when I first looked at it, there's actually another crystal mounted under the Atmel chip here, and what I couldn't figure out is why anybody would bother to put two crystals on here, because if you've got a crystal powering up the 80 mega, you don't really need another crystal. You don't need that level of accuracy. They could have just used well, I suppose they still could have used it. I don't know why they just didn't use the internal oscillator within this chip, assuming it's got one. It probably has. So I'm assuming maybe this is a real-time clock here, and maybe that's what the button cell backs up. And where's the temperature sensor? So yeah, that's basically the temperature sensor element, that little three-leg job there. So I realise the camera's not focusing very well. So again, there's a little blinker that I built. It took a couple of hours to build. I'll put a link into this on eBay where I bought it, and I would actually say it was quite a lot of fun. You don't need any fancy soldering equipment to do it. You can assemble this with a normal soldering iron. If your eyesight's not so good, I guess a magnifying glass or a bench-mounted magnifier would work wonders. But yeah, I managed it just using a normal soldering iron and some thin solder, and again a little bit of liquid flux helps when you're doing surface mount as well. So yeah, sorry, waffling a lot now. So I've been building a few battery projects. That's where I came into this. This is one of them, and I kind of thought, well, I haven't got anything with batteries in it. So when I was walking around the radio rally, I saw some of these battery holders, and I think I scored the whole lot of them. It says £1.9 here for this one, but I think I paid £1 for all of these. So yeah, I was quite pleased with that. Oh, that's quite a nice one. So this is one has got a little box with it, and you can switch it on and off. In fact, that's just giving me a little evil idea. Ooh. I love the smell of ozone in the morning. It's really quite nasty, isn't it? Yes. What could we possibly use that for? I have no idea. Well, this is quite a nice little box, really, isn't it? I'm sure it's got lots of uses. So, of course, this takes AA batteries, and I've been putting the nickel metal hydride batteries in it. So we've got one of them. We've got one of them. Oh, this is a smaller one, so that was AA. So this one must be for AAA. And I'm guessing 3 volts is quite a handy voltage now to have for, well, there's a lot of 3 volt logic around, isn't there? So that's got a little, is that a little micro Molex connector on it? I'm not sure what they call them. So got one of them as well. Well, that's interesting. We've got a 9 volt to, well, I always forget what you call them, but you know what it is. It's one of them barrel connectors, typical power connector. And yeah, I wonder if that's centre positive. Let's check that, because that could ruin your day. You never know if you've got something that runs on 9 volts. Let's plug that in and give it a try. Yep, centre positive. It looks like what we've got here is we've got a lot of D connector shells. And these actually look very similar to some D connectors I made up the other day. In fact, let's get that out. Well, do you remember last week we were building the Z80 computer? Well, here it is, it's all built. Don't want to talk about it because that would be a little bit of a spoiler. And I'm not going to show you running today because I want to make a video on its own showing that. But again, I haven't got time to make that at the moment. But what this uses is it uses a Windows laptop running a terminals program to do the user interface. So I needed to plug this into the computer, and it uses the 9-way serial connector. So I made up this lead. Well, actually, I found the lead with one end on it, and I cut up another lead and found another connector and soldered them together. And yeah, I can never remember it. I think, is it a null modem cable where you swap over pins 2 and 3? Is that a modem or is it null modem? I never really understood null modem. Maybe anybody. Well, I understand what it is, but I can't. It just seems really confusing, the fact that some cables you had to swap the transmit and receive over, and some you didn't. And I think they used to call them null modem cables, didn't they, when you swap the transmit and receive pair over. So that's all this is. What I will say is I did spend rather a frustrating half hour trying to figure out why I wasn't getting comms out of it, and double and triple checking everything, and only to discover that yes, I hadn't quite figured out the twist. Okay, enough said. So while I was walking around this radio rally, I saw this big bag of connectors, and Again, it was a pound, and they're quite expensive to buy these shells when you buy them separately. Let's just have a look at one, because it looks very similar to the ones that I've got there, which I think came from RS, and normally they're like £3 or £4 each or something. They're not particularly cheap, these things. Yeah, I actually think it is exactly the same connector. So basically, you've got the outer shell. You've got like a cord grip here that goes around the cord. Let's assemble that up. Yeah, I'm afraid the camera doesn't really like focusing on things that are shiny. So yeah, that's what the completed connector would look like. So as I was trying to explain, these screws here on the side are the ones that actually hold it onto the back of your computer port when computers had 9-pin D connectors on them. That's where the cable would come out, and you can see the strain relief rattling around inside. And these are the screws that hold the connector shell together. And again, as I said, they're normally quite expensive, these. So I think I've got probably pretty much a lifetime supply of D connector shells. And yeah, £1. Not complaining. The only problem with buying all this stuff though is you need to find somewhere to store it, don't you? And I'm already limited on storage space. And these look like, well, I think, didn't they used to call these DIN connectors, DIN? Is that a German standard DIN? So basically it looks like we've got, well, we've got a number of different plugs and sockets here. It looks like we've got more sockets than plugs. So we've got some 1, 2, 3, 4, 5 pin arrangements. There's another internal. Is that another 5 pin? Oh, maybe this buy didn't work out so well, because I've got the I've got what I assume is the hood for the connector there, and I've got some of these inserts. Maybe that's correct. So that must go on there like that, I'm guessing. Maybe it doesn't. Oh yeah, it does. And then that pulls into there, and then it gets retained by a screw. Screw's not included. So yeah, it looks like that wasn't such a good buy. I've got some incomplete connectors there. Well, I've got lots of sockets, haven't I? So can't complain about the sockets. Again, used to find these on a, well, I'm just thinking of my granddad's old tape recorders. He used to buy lots of these. Well, he was like me, he used to collect junk as well, and Grundig is the name that I remember. Grundig tape recorders and Grundig radios and things like that. They always had these DIN connectors on the back. So we've got a lifetime supply of them. Looks like that one is actually complete. That's got all the parts up to make the actual plug part, whereas yeah, we seem to be missing the internals to do these. Ah well, again, not complaining. And in the same bag there's this 3-pin connector, and this looks like, I wanted to call this a bulging connector. I think it does have a name, but I've forgotten what it is. But I just recognise this. This is the same size connectors that the old Weller soldering irons used to have on them. Do you remember them? They were kind of light blue coloured. Was it called Magnastat? They used to have a little magnet inside and a little reed switch, and as the soldering iron would heat up, the magnet would demagnetise, and when it got to a certain temperature, the reed switch would drop out. The magnet had cooled down again and then become magnetic, and I think that's how they worked. And they called them magnet. I think they called it the Magnastat range. And I've had lots of those old Weller soldering irons. I mean, I've got a modern digital controlled one now. Everybody says that they're the bee's knees, but to be honest, I had Wellers for years, and yeah, nothing wrong with them. So that looks like a, well, I'm going to call it a Weller connector stroke bulging. It also looks a lot like the same connector that they have on the quad amplifier. Is it the 303 amplifier? I've got one of them somewhere. I'll have to have a look at that. Well, we've got a lot more of those jumper cables. In fact, I've got again, probably another lifetime supply of jumper cables. I shouldn't say lifetime supply because I'm hoping to live a few more years yet. And these are similar to the ones that you've seen before that I was using on the you know, the logic analyzer, where I made up some test clips. I say they're similar, they're not the same, because the ones that we had before were female on both ends, where these have got a male part on one end, a little stabby point, and they've got a female point at the other. But that doesn't necessarily bother me. I think they'll be quite actually handy for making up little jumpers. Now the question is, do you remember last time that the connectors that we had, the cables, were made out of, they were iron, weren't they? They were magnetic. So are these made out of copper? Are they any different? Let's see. Oh yeah, looks like we've got copper this time. Yeah, good. So yeah, we've actually got some copper cables there. And if I need to make any more probes for my logic analyzer or stuff like that, I've now got some. Yeah, they're really handy then. So I assume these will fit in here okay. Oh, they're a nice fit, nice tight fit. So we've got lots of them. That's a female one. There's another male, male to male. Well, not much more you can say about them. They seem fine, and they're always going to find a use, aren't they? And this is quite obviously an LCD module. I don't know much about it. I'm just hoping it's going to follow that standard Hitachi driver layout. What can we see? Pin 1, pin 2, pin 15, 16. Yeah, well, it's an LCD, isn't it? Obviously backlit here. I can see it's got the anode and the cathode connections there. I don't know whether it'll just be LED or if it'll be one of these that requires the you know, the high frequency drive. If it's got one of the fluorescent backlight systems, I don't know. But again, I just bought it because it looked, it's a bit dirty and dusty, but it's never been soldered to, so it looks effectively like new. And again, we might have a project in the future where we want an LCD module, and that's a nice big one, isn't it? More connectors, got some IEC sockets here. Again, always handy when you're building projects, aren't they? IEC connectors, we'll find a use for them. I was almost there, very tempted to plug one of these in, but given that this lead I've got in my hand is my live cable, I always keep this plugged in on the bench because, you know, everything has these kettle leads on it, these IEC connectors. Yeah, yeah, that would end badly, wouldn't it, if we plug that in? Now, I'm really tempted to plug it in, but no, better not. Here's a big one. So I actually splashed out a little bit here and paid a whole £10 for this, which, well, I think it doesn't really need a lot of explanation, does it? It's just a power block. He said if you can undo the thing. Come on. Ah, God, too bad-tempered. Criminal, cutting a releasable cable tie. I assume this is the people that have made it. Olsen's Electronics Limited, Stanmore, Middlesex. Looks nice anyway. You can never have enough plugs on the bench, can you? And it's a nice pretty colour, and it's got an isolator switch on it, which is handy. Alright, okay, that's good. So whenever you actually turn the thing on, this fuse symbol here where it says fuse, and I'm guessing there is a fuse under there, I don't know how you get it out, but the fuse lights up red, and that's just showing that there's power going to the block, but the block itself is, I'm assuming all these sockets are still turned off, but you can actually turn them all on or off there. And some more not very exciting D connectors here. So they look like they are, again, male 9-way, but these are right angle PCB mounted. So I thought these 9-way connectors being PCB mounted would be quite useful because, as I said earlier, I do tend to make my own PCBs, and yeah, I can solder that down to the board, so that's going to be useful. Got a bag of 1K trimming capacitors here. Don't think they're particularly high quality. Are they all 1K? Yeah, they all look to be 1K. But yeah, that's not a bad size to have, is it? 1K capacitors, 1K size. It's pretty common. So we'll find a use for all them for sure. Well, I can't tell you much about this. I think it's an old computer hard drive. It's made by a company that I don't recognise. It says it's made by Connor Peripherals. I'm assuming it's that's an IDE connector. So I've kind of been looking out for old DOS machines, and I was hoping I would, you know, find an old computer at this radio rally. But you know, as it happened, didn't see any old computers, but I did see some old hard drives. Bought a couple of these. They're both identical, and I paid 50p each for them. I just thought it was interesting, and if at some point in the future I get more into old PCs, I've potentially got a hard drive to play with. I also bought this bottle of liquid flux, and again, don't know how good it is. I mean, you see these things at radio rallies, and you know, they say how brilliant these things are. Why did I buy it? Well, the main reason I actually bought it is because it's got the little brush on it. I do use liquid fluxes. I'm going to sniff this because you have to sniff chemicals. Let's give it a sniff. I've got to admit that kind of smells uninteresting. VOC free, no residue, sustained activity flux for lead free and tin soldering. I think that this, I was going to say this is used for surface mount, and maybe I can use it for surface mount, but this is much more likely the stuff that you used to use for solder wave soldering. If you've ever, well, again, I guess some of you who've worked in electronics factories will know what solder wave machines are, flow soldering machines, and they, before the board goes in the bath of tin, it actually goes over like usually like a little, I don't know what you call it. It's like a slot, and it has foam coming up from underneath it, and it rubs against all the pins and the copper side. And this foam is, well, it smells like this stuff. It's like usually a water-based flux, and you know, before your circuit board goes over the solder wave to get soldered, it first of all gets covered in a layer of flux. Let's try it without some flux first of all. I'm sure it's going to solder fine. Yep, that wasn't any problem. Let's paint some of this stuff on, see if anything exciting happens. Can't see that it will. I do think the interesting thing on here though, I think the fact that it says it's an active flux means that you have to wash it up afterwards. I could be wrong. It says it leaves no residue, but I think you probably have to wash this stuff off when you've done a board. I don't know. Right, we put some of that on. Is that going to solder any differently? Oh, actually, it does. Yeah, it does help. Yeah. Oh, actually, I'm quite impressed with that. It really does suck the solder off. Wow. Oh, come back, all is forgiven. Probably find out it's like that old plumber's flux. You used to be able to make fluxes, didn't you? I think you used to get sulfuric acid, and then you would cut off bits of tin with your side cutters, and you'd drop it into sulfuric acid, and basically that would give you your own, well, basically your own flux for when you're soldering up the radiator on your car and stuff like that. I think that's how my granddad used to use flux. I think you could use that for brazing as well, I think, for you know, for cleaning the metal. And then the other thing you used to use for brazing is borax powder. Yeah, borax. Back in the day, eh?